Okay, we will present about Maglev train, which stand for magnetic levitation train. Maglev train are major investment in transportation technology. They are using a principle of electromagnetism to move without touching the track, which means there are no friction during the motion. This topic important because maglev train offer faster travel, higher efficiency, and more environmental friendly compared to conventional train. Therefore, maglev technology is a great real-life application of electricity and magnetism that we learn in physics. The objective of our presentation are two main points. First is to help everyone understand how maglev train work. Second, we explore the current use maglev train and their future potential in transportation. Okay. Next, I will explain what if maglev technology is. Maglev or magnetic levitation is technology that uses electromagnetic force to lift and move vehicles such as train without physical contact with a railway track. Because there is no direct contact, friction is greatly reduced. There are two main types of maglev system. First type is electrodynamic suspension, also known as EDS. This system uses superconducting magnet to create strong magnetic field that repel the track away from the track, allowing a levitate. Second type is electromagnetic suspension (EMS). This system uses normal electromagnet that attract a train toward the track, keeping the levitate in a stable position. Both systems magnetic force, but they are different how its levitate is achieved.
Take a closer look at the principle of magnetism that make the maglev train work. First, we have electromagnetism and magnetic levitation. This is based on the Lorentz force which act on the train due to the interaction between electric currents and magnetic field. The Lorentz force is responsible for both levitation and propulsion, which means it lifts the train and moves it forward. Next, let's talk about the magnetic field. The train relies on strong magnetic field generated by superconducting magnets. In the case of EDS or electromagnets in EMF to achieve levitation. These magnets interact with the track magnetic field, enabling the train to hover without touching the track, thereby eliminating friction. Moreover, how maglev use electricity and magnetism. Maglev train use two key ways, which is levitation and propulsion. For levitation, superconducting magnets or electromagnets create a force that lifts the train above the track. For propulsion, linear motor on the track generate moving magnetic field that propel the train forward. Now let's look at some real-world implementation of maglev technology. First, the Shanghai maglev train in China is the world's first commercially operational high-speed maglev train. Opened in 2004, it has reached speed up to 431 km per hour, making it one of the fastest trains in the world. This train connects Pudong Airport to downtown Shanghai, covering a distance of 30 km in just about 7 minutes, showcasing how maglev can drastically reduce travel time. Next, in Japan, we have the SC maglev, which is set to revolutionize intercity travel. This train can reach speed up to 500 km per hour, making it a significant leap forward in speed and efficiency. It will connect major cities like Tokyo and Osaka, drastically reducing travel time between them. SC maglevs use superconducting magnets for both levitation and propulsion, making it a highly advanced system for future transportation. Moving on to the benefit of maglev train. First, maglev trains are known for their speed. This train can reach speed over 500 km per hour, which makes them much faster than conventional train. This is ideal for intercity and long-distance travel drastically reducing travel time between cities and regions. Secondly, frictionless travel is a major advantage. Since the train doesn't physically touch the track, there is no friction between them. This not only makes the ride smoother but also reduces wear and tear on both the train and the track, leading to a lower maintenance cost. In addition, maglev trains are more energy efficient. The lack of friction means less energy is required to propel the train, making maglev system much more energy efficient compared to traditional rail system. Furthermore, there are significant environmental benefits. With no physical contact between the train and track, maglev trains produce less noise pollution, making them a quieter transportation option. If powered by renewable energy, maglev train can also contribute to a greener and more sustainable future. Finally, the comfort of maglev train is enhanced due to the smooth and frictionless ride. Passengers experience a smoother ride and more comfortable travel compared to conventional train.
Next, I will talk about the challenge of maglev train. Although maglev train offer many advantages, there are several problems that limit their use. The first challenge is the high cost. Maglev train require special track and station, which are much more expensive than normal railway system. The second challenge is the technology itself. Some maglev systems use superconducting magnet that must be kept at very low temperature. This makes maintenance more difficult and increase operating costs. Another challenge is limited usage. Currently, maglev trains are only used on a few roads around the world, which make it hard to expand the technology. Lastly, because of the high costs and long construction time, it can be difficult to get strong public and government support. Despite this challenge, maglev technology continues to develop through research and innovation. One important area of development is high temperature superconductor. This material can operate at higher temperature, which reduce cooling requirement and lower operating costs. This makes maglev system more practical and efficient. In the future, maglev train may also be integrated with other transportation systems such as airport and high-speed rail network. This integration can improve connectivity and reduce overall travel time. There is also potential for long distance and autonomous maglev train. Autonomous operation can improve safety, reduce human error, and increase efficiency. With this advancement, maglev technology may become more reliable and wide. To conclude, maglev trains are an advanced transportation technology that applies the principle of electricity and magnetism. They use electromagnetic force to levitate and move at very high speeds without touching the track. We discussed how maglev trains work, their real-world application, and their benefits, such as high speed, energy efficiency, low noise, and reduced environmental impact. However, we also identify challenges like high infrastructure costs and complex technology. In conclusion, maglev technology has strong potential for future transportation. With continued research and development, maglev train may become a key solution for fast, efficient, and sustainable travel in the future.